Hey everybody, this is Garrett Sharpe. This is my lab 5 on collisions. We're using croquet balls. Main ideas and principles for elastic collisions: initial and final kinetic energies will equal each other. For inelastic collisions, this is not the case. They will not equal each other. Energy will be gained or lost, usually lost. Main two principles: energy principle, change in energy equals change in assorted types of energy such as kinetic and internal energies. Kinetic energy is equal to 1/2 mass times velocity squared. And we're also using Newton's momentum principle, of which change in momentum equals F net times change in time. So we can rearrange that to find the net force. Conservation equations. Conservation of momentum is just that initial momentums are equal when added together to the added together final momentums of the objects in question. Conservation of kinetic energy. Um, Initial kinetic energies are added together and they should equal the final kinetic energies. If not, then energy has been lost as internal energy. So here's my tracker file. The croquet balls hitting each other. As you can see, energy is transferred from the ball on the right to the ball on the left, and they're moving in the negative x direction. Time starts at 0 and ends at 0.5 seconds. And you can see right here on this graph that right about at 0.2 seconds, the impact occurs, changing the velocity of ball A and also the velocity of ball B from 0 to some number. So using different formulas, we've calculated that and we found these values. Balls 1 and 2 both mass at 0.453 kilograms. The initial velocity of mag velocity of ball 1 is negative 1.21 meters per second. Final velocity of ball 1 is negative 0.361 meters per second. Initial velocity of ball 2 is 0 meters per second. Final velocity of ball 2 is negative 0.891 meters per second. And as you can see, we calculated the final and initial total momentums, and they do not match up. Now, there was actually a speed up of momentum, and there are a couple reasons for this. This does not mean momentum was not conserved. Now, it could be that the floor was slightly uneven and listing a little to the left, putting a slight incline, and the ball might have picked up speed rolling down it as the earth put a weight force on it. Or it could be that the tracker point masses were not correctly placed, giving us slightly inaccurate data. And the net force on one was found to be 5.75 newtons, and the opposite amount of newtons, negative 5.75 newtons, on the second ball. And using the momentum values and change in time, we found the initial kinetic energy to be 0.331 joules. I bet we used just mass and velocities. And the final kinetic energy is 0.209 joules. So kinetic energy is lost from this system. This means it most likely went into a change in internal energy of 0.122 joules. This could be thermal, vibrational, or rotational energy. And so this is a non-elastic collision. All of the velocity, mass, time data, and net force data into a VPython file to be able to graph the velocities and the position changes. And if we run this module, we end up with the blue ball moving in the negative x direction, making contact with the red ball and creating the impulse force, and sending the ball to the left while slowing itself down. And if we look here, we see that the velocity, final velocities equal the initial velocity, where this is roughly negative 8.5, this is roughly negative 3.5, and they add together to equal the negative 1.2 one velocity of the initial conditions. And so because the masses are the same for the two objects, theoretically the momentum should be conserved, and likely was the non-conserved momentum was due to mass change errors. Mass errors probably also occurred here. As you can see, this is the theoretical graph, and I'll pull up the experimental graph now. As you can see, they look relatively similar, but the experimental is a little more jagged, which is likely due to the fact that, as I said, mass center errors. And so I hope you enjoyed the lab. I'll talk to you guys next time.